Oh, it's sending link to the parents. Huh? What? Oh, later I think I'll be recording since here, right? I'll send you the link on YouTube. So.
Okay, I'm talking.
Will you watch it now or will you watch it later?
Later, you see your course? So, I cannot do so.
Oh.
So, I can't get your sheets.
I don't know, what's the audio?
So, the audio no one.
No, the audio one.
Oh, bro.
But the volume no.
So, I can hear myself.
I just get this.
Let's see.
I just get the link there.
Yeah, that's something I want to meet the YouTube, so just to go YouTube, fill out YouTube. So, when you went to class, how about last week Friday? Still, yeah, how you see people in cars and
Right, so on the test starting, was it the meeting? On the test starting on 2 weeks from now. So the week after next, okay? That's the 20 or 30th of the week. To the end of this month. Okay?
Yes,
Right there?
yes.
Okay. You give me a box. No? Who wasn't it that close? When I when you
no, 15.
how much you have I got on this? 17. Well, now be enough, right? 17 of the 20. Right, so we're gonna do we started with ironing bonding yesterday. Let's do properties of ironing. Properties. Last class. Properties of ionic compound. Right, I require down. I take on again. Properties of ionic compound. What are ionic compounds again? What's an ionic compound?
Compound that I want to be one.
Right, and what's ionic bond? Between a metal and a non-metal, right? So an ionic bond is formed when a metal donates its electron to a non-metal, right? I remember that. Everybody remembers that.
Yeah.
Right. Alright, so what kind of charge does the metal get after it donates its electron? Positive. What kind of charge does what kind of charge does the metal get? Negative?
No, positive.
So why is it negative?
No, say, you say metal, who's the news one, please?
I would like to know this. Okay. We're going to ask the question, right? Right? Take down here the properties of ionic compounds. Right, so ionic compounds have certain properties because of their bond. And we have to know these properties often.
More electrons, sir.
Huh?
More electrons.
So the first property, ionic compounds. Ionic compounds. That's the first. That's a prize. How do this? It's on by. Right? So, right, properties are the compound, the first one, and the compounds have a high, and the compounds have a high melting and boiling point. Have a high melting and boiling point. Okay, somebody give me an example of an ionic compound. Yes, you do.
H2O.
No, that's cool. And the easiest example to remember for ionic compound is sodium chloride. Right, which is salt. Right, so all these properties are listed here is for salt. And we know this is an ionic compound because sodium is a metal and chlorine is a non-metal. Right? So sodium chloride, salt, if you're trying to boil salt, it'll take a while to melt. Right? And the reason is to have a high melting point. Okay? Well,
I'm sure I'll do.
it's not as high as salt, but higher than water. Right? Salt?
Yeah. It's like a relative. Okay,
Now you gotta separate the sodium from the chlorine. That's all.
We'll say if you do it.
You can do that.
Yes.
Right? Okay. Second property. Right, so can you all think ionic compounds can conduct electricity?
Yes, sir, yeah.
Yeah? So the answer is yes and no, right? So if I try to pass electricity through salt, solid salt, it would move, right? However, if you pass it through salt dissolved in water, it could conduct electricity. Right?
No, I'm not the answer.
Because there are free electrons in that one. Right? Remember, salt dissolves in water, so in the aqueous state, ionic compounds can conduct electricity. So it means water dissolved in water.
So aqueous.
Aqueous means dissolved in water. Yeah, well, it's dissolved in water. Right? So can ionic compounds conduct electricity? Well, your answer would be
Yes.
Yes, I do.
well, it would be yes, but
But yeah, only
only in certain conditions. Right? In the aqueous state or molten state. Molten meaning melted. You understand? I'll put on here. Ionic compounds. Ionic compounds. Ionic compounds can conduct electricity. Ionic compounds can conduct electricity when dissolved in water. When dissolved in water.
What is this?
Or when or when they are or when they are in a molten or when they are in a molten state. Or when they are in a molten state. So you have to know.
Yes.
So what else is on there?
是比赛当西是的，我在玩这个东西。
Okay, but this time I think more.
You know, when you build a magnet, the optic of a magnet, how is the most because it's you be that much magnet we have.
Is the money. I can't tell you why it should be. I can
Say because like the like the button the fast and I say go on.
Yeah, but I'm not sure what. I will tell you. I know it does lose the magnetism, I just don't know what. Same thing if you drop the magnet, right? Right. Kind of.
It gives me about like 6 hours.
Huh?
What?
In the hole.
Everyone wins.
In that side. Next side.
A white tool, sir.
The end of the wood.
Yeah, that's what a white tool, right? A white ground that will connect when everything's. Yes, it is. A white tool.
Well, we already know, right? Nobody knows what's the end of a black.
Black bullets, we talk the front like the.
How are you?
So I was not geography.
That's not National Geographic.
Discovery science.
Okay, but how do you know that?
And that's about two different times in National Geographic.
Okay, I'm not disputing that, but saying how they know.
Me I one
end of a black.
scientific experience.
But 500 go like the value in
You only know what the end of a black hole is, you know, through a black.
So, but sure, you want like really kind of go in. But you like do this one. That's real. It's not. It's look at what. You just shut it.
I don't know if it's done.
Yes, I will stop. Just to watch the kind of
What is the decision, right? Alright, so point,
end up under a part.
the point, right? Are ionic compounds soluble in water? Yes or no?
Yes.
Right? So that's what I remember the example of salt. Salt is an ionic compound, and salt can dissolve in water.
Yeah.
Right? So one of its properties is that ionic compounds are soluble in water. Right in that, right? Ionic compounds are soluble in water. Right? So the easiest way to remember the properties, just think what salt would do. Right? And the last one, right? They have a crystalline structure. Yeah. To an extent, they have it, or is refract light. Right? So you know, like if you shine light through a diamond or you refract the light, a refract light to some extent. So they have a crystalline structure. And I'll show you all. So you'll understand.
Experiment.
Like transfer.
Another experiment. We could draw like crystal in the beaker.
You can draw the crystal.
No, like drew it is drew.
Yeah, but that doesn't mean so careful.
Where's me?
It depends on where you use it. It's yeah, the compound.
So for top 5.
Just video more.
No, it is not.
Yes, it is. Yeah.
It has 3 questions.
Huh? Yeah, there's education. This is educational, right?
More people now. It's one of our.
These giant ionic.
Alright, Daniel, look at the video. Shakir, Nathan, go ahead. Oh, you need captions?
Yes.
Structures. When we talk about sodium chloride, there aren't actually any individual sodium chloride molecules. Instead, the sodium and chloride ions are arranged in a regular repeating 3D pattern known as a giant ionic lattice.
I could draw that there.
No.
I got the lid.
Still got it.
Huh?
What's that?
And if I bring an example, what you want to She cheated now, you know, all of you say what cheat.
Sure, but he's saying he cheated, right? But she get cheated. Yes.
She did.
Let's now
Yes, sir.
have a look at the giant ionic lattice of sodium chloride. We know that sodium and chloride ions are electrostatically attracted to one another. Because of this, you will see that the ions are arranged so that the sodium ions are always next to the chloride ions. This arrangement
I'll pick up on the director. No. I basically tell them that it's on the next
So which one? Which one? This one you want me for?
cube, but
So we can't
is seen in all directions of the 3D structure. The electrostatic attractions in a lattice structure are very strong. Let's think about it. Each sodium ion is held in place by the electrostatic attraction of 6 neighboring chloride ions in all possible 3D directions.
what causes that causes the attraction in sodium chloride?
abundance.
The force, when you type of force.
So when you get up?
Why is it here?
That's okay.
Anybody hear that?
6.
What's the type of force that causes attraction? An ionic compound.
Plus negative.
Positive and negative. What's the name of that force? So, correct.
Electron.
Electro something.
Oh, electron,
Say that, you're gonna say something.
So something like it's in.
Electrostatic forces, right?
Strong. Let's think about it. Each sodium ion and chloride ions. This arrangement is seen in all directions of the 3D structure. The electrostatic attractions in a lattice structure are very strong. Let's think about it. Each sodium ion is held in place by the electrostatic attraction of 6 neighboring chloride ions in all possible 3D directions. And similarly, each chloride ion is held in place by the electrostatic attraction of 6 sodium ions, also in all possible 3D directions. Since this lattice structure is so strong, it explains some key properties of ionic compounds. Ionic compounds have very high melting points. This is because a lot of energy is required to overcome the strong electrostatic attractions holding the 3D lattice structure in place.
Yeah, right? So I give you all the points. Okay, this is your reasoning behind the point. Why does ionic compounds have a high melting point?
It requires a lot of energy.
Yeah. Right, so because they are strongly bonded, they're going to take a lot of energy to separate them. Okay, that is why the melting point is so high. Remember, when we refer to melting point, we refer to temperature, right? The higher the temperature, the more energy you take it to break that bond. Right, so for example, if Shakir and Shakir, right? If we try to split them apart based on how close they are together right now, will it require a lot of energy or a little bit of energy? Right, and if you try to split Zoe and Ayana apart, will it require more or less energy? It requires more energy, right? Because they're closer together, they're more strong bond. You understand? So the reason ionic compounds have a high melting point is because of their strong bonds, but strong attraction to each other. You understand the reason, right? Yeah? There's some reason? You done?
Yeah.
Sure? Alright, what's the next key property do you answer? Can we read the same thing?
Simulation.
Is it?
Simulation are similar because electrostatic.
Which one?
So electrostatic attraction is like very strong and
Ionic compounds are also very brittle. This means that they break rather easily into small pieces. A ceramic flower vase is also brittle. If knocked over, chances are it will break into small pieces. But why are ionic compounds brittle?
Yeah, like computer screens and stuff, right? Like monitor screens and things. Right? I remember when you were at so. What it was touch. Right, but for future reference, screens are brittle, so do not hit them.
Well, what is that's what happened yesterday.
Listen,
He's talking.
anybody get it?
Oh, I know. Oh, very.
I have a slide battery,
No.
sure?
Yes.
Only the street.
So it's like
Yes.
I'll just like I'll go soon.
Hey, everybody watching the video.
When a force is applied, repeating 3D pattern of alternating positive and negative ions, ionic compounds have very high melting points and are brittle.
I told you the joint structure.
No.
Well, I tried something.
So guess it won't.
Wait,
Yeah, do. Put out the there. Alright, so I'm gonna help on the joint, right? Actually, no, I'll try.
No.
I'm gonna show on it, and then I'll try. Right, I'm gonna go in 2 minutes, try and pencil, and then I'll show you all.
But still, I got us running too.
So just get back on it, check it. See,
I'll get it. You know, you can join. That's simple. So you can do it.报位置，报位置。换到位置的。不是的，是吧？Yes, alright, so let's join, okay? Is it? Confusion over me. So it's a structure of stored, right, specifically, and you see try to figure out the pattern, real simple. Like that. Well, you could, you know, but it'd be difficult. Alright. I'm gonna talk all the others.
Because you have a video. So, say the beach on top of the plane.
Ayana, close the laptop. Everybody, we don't need our laptops, all right? We can put them. Honest? Yeah. On a good drive, the 57 seconds. Go easy to. Alright, let's pay attention. Ready? What? Right, so we're gonna play it, right?
下次我玩那会儿，靠哪看着？
Let's do pencil, and then shape the,
下次我看谁呢？
play it, right? Is there a square? You all know what square is, right? What is a square? Right, so Shakir says that a square has 4 equal sides, right? So when you raise your hand, what is a square?
A square, 2
4 equal sides, good. So you're drawing 2 squares, look how you're drawing 2 squares, right? And using a ruler. How you gonna square to use a ruler?
Yeah, that was well, that's unequal.
There you go.
We're not in balance.
What's it doing? You have to start with more.
You must be trying. Come on. What?
Nathan, Nathan, we will like this. You keep on a square, the very time.
So they talk about, we have products. So, was driving that.
Okay, so ang ating
So that's all I'm gonna be here.
Hey, everybody have pictures?
Yeah.
No, but it's 2 squares, 2 different lengths.
Then it's not square.
Oh.
Right, so this you're drawing 2 squares of the same side, no, we learning how to draw sodium chloride. The structure of sodium chloride.
Just playing.
There.
Yeah.
Okay, it's not my.
Shut out. Shut out.
Sodium chloride, NaCl. Right, so we have our 2 squares.
Yes, sir.
8. How come half of the class got rulers?
Yeah.
That is my.
Who got ruler in the class, is there? Right,
My name is Amanda.
I'll tell the parents to get a ruler for you, please.
I had a break yesterday.
Okay.
I could have.
Right, if I got a ruler by tomorrow, I'm gonna send a message on the group chat, right? Yeah, I know. Why you need it? I don't, I say they want to buy a ruler for.
So we have, see that you.
So they want to go ruler. But they only.
So we're like about, wait, the camera up, so.
Right, I'm playing the video, right?
You wanna wear my.
No, no, it's okay, I done it. That's right. Stay inside. My next square of the same side. Why you go to which part of the instruction?
We're gonna draw next week.
On this side. Huh? Yeah, the people. What?
Something like that.
And it's simple, watch, just draw a square. Just draw a square. I use a ruler, don't worry. Right? You draw a next square. Huh? We'll make a nice place, yeah, we have a space. Yeah, there we go. Alright, so 1, 2,
Leon, who's it on me?
right, just draw 3 squares like this. Alright, you got it. Watch.
So,
This is 20 centimeters, this is 20 centimeters, this is 20, this is 20. So. Alright, 3 squares.
hey, Baba, I'm touching.
Should you stop touching me, son?
I don't like it.
Here, stop touching me, son. Like you're being very inappropriate. Let's see who do this. Huh? Huh? Really?
You pass all over here. You know.
Sure. So this was actually pass on.
So why look at it? They found that. So what was I looking? Look like it draw like this line that I can that's way.
Yes,
Something like this, right? Damn, sit.
I like you, man. Okay.
They don't have that.
Alright, everybody have 3 squares? Right? Don't connect it yet.
Yeah.
Alright, the next step. I'm squares and crosses. Right? So this is your first square, you divide it into a cross. Right? Yeah.
No one else.
Huh?
There's a one.
Cubes. Or you check what you're seeing.
I don't think.
Or I could watch something and see who's cubes.
Yeah, you're just smart. You're just smart.
You won't watch the audio.
Shakir, exactly.
Yo, a cross and finding the right squares. And your cross. All the way across. Right, draw the cross, draw the entire individual square. Right, so this is one cross here, one cross in the second square. Yeah, okay, like that.
I feel like my brain
Over that. You think of the right? Right.
Yeah, well, you can watch mine. You know.
Yeah.
That was so.
But now you're doing it up.
It's gonna.
You was doing it. Why are you doing that?
What you can see. That was.
You, yeah, you, two on the You can sit down. Make it sit down.
It's like that. Your heart. Yeah, I should go see your mind.
Black balls. No, I show all your tweets on the board. Right, next up. So instead of talk.
I'm done.
All I'm doing is I'm meeting the corners. So this is the corner of your first square, right?
Yeah.
So you're just connecting this corner with this corner. And then the second square corner, you're connecting it with the third square corner. Simple enough?
No.
This is the simplest part, connecting the corners.
What's looking very confusing now? I think I just tell me draw a cube, easy enough.
Yeah, you got it. Don't really like it.
Thank you. Nothing. I'll see you guys.
I'm trying, I mean.
That's my job, Shady. My bad. Who's that? Who's
Yeah, kind of. It was a lot. Are there anything except?
No. I think I can bench you.
Let's just see how it comes together. Take a little box too.
Sabe onde meu liga?
The cross, the bottom of the cross.
Não sabe, não sabe.
This side. Wait, please, I can't the bottom of the square.
I guess so. I guess.
No, no, I wish you know this out. Which part you? You'd have to connect the lines now. Oh.
Yeah.
So we say should I help you? Yeah, making sure they do all. Actually, yeah, making sure they do all. I can buy them, please. No, the budget, we love to. Right, I'll inquire. So this is how you arrange the items, right? So what are the two atoms involved in sodium chloride? Chlorine, right? So this is how you arrange them. So you have to do something to represent sodium color. You have to do something for sodium and you have to do something separate for chlorine. If you do two different colors, like you shade one and keep one on change. Parts of it. So like say we have a sodium, I using dark circles for sodium and empty circles for chlorine. Right? So if I start in the corner, right? If I start with sodium, the sodium could only be connected or bonded to chlorine. So if I'm going from this corner to here, what have to be here? Right, so if you have chlorine here and a chlorine here, so what we in the middle here? And sodium, right?
I don't have language in the middle.
So then you're missing something. Yeah, we can figure it out. Right, so in the corner, there's bringing sodium chloride. Again, part of it. And sodium can only be bonded to chlorine, and chlorine can only be bonded to sodium. They can't be bonded together. A simpler way to do this, I don't know why they didn't start to do this, and they couldn't do this, right? Sodium to chlorine.
Darling, everybody knows that.
Sir, I think we have following these, and our votes, that's what you want to do. And you want.
If I find this smart to draw, I can do it like this as well.
They know when they tell me that's true.
Hold on, let me finish this first.
I never want to get flipped to each other all the way around.
Right, so you all understand the pattern?
No.
What is the pattern?
Any bottom ones, the 5 sodium.
No, that's the pattern.
Corners is stuff like the corner is sodium and the sodium.
It's switch.
It doesn't matter, the only thing that matters is that the sodium is bonded to a chlorine. You all see that? And this chlorine, right, what is bonded to? Is this chlorine bonded to any other chlorine?
No.
No? Is this sodium bonded to any other sodiums? It is? No? This is the bonding pattern. Right? They cannot bond together. They can only bond with the other elements. Right? So this is the next way you all could draw it. If you all don't want to draw the cube. Everybody understand the pattern? I don't know why you want to draw a cube one thing. What are you going to draw? I thought that would be good. I know it's do art and thing.
So what?
We don't care about
So what?
That's not confused now. So, I'll finish these 3 sides here.
Right?
Nah,
You can syntax volume, you just have 2 lines in the main thing is what I see, chlorine bond to sodium, the sodium bond to chlorine, send them together. So can you do this, right? I just want to show you all something. Right? Ivan, watch it. Can I bond this sodium to this sodium? Why not?
Because it's at the same time.
Right? They have the same charge. Are they actually key reasoning, right?
Yeah.
They have the same charge, so they cannot bond together.
Stop
Well, use dark circles to represent it.
Stop me,
So if this competition, I do it like that,
Or like
so I'm testing on this.
square one,
Yeah, 4.
you get it.
So what happened?
Yes.
So I'm testing the girls,
The square one, yeah. But I would prefer for the draw a cube one pair.
But you get marks for that?
Yeah, you get one.
Full mark?
No.
Yeah, you get one.
So you get
So you'll get full mark. One is correct. One correct.
Okay.
One is- Huh? Maybe. Maybe not.
Like, but I like 120. I know 120.
No, what's that? So it's not 130.
I know how to.
Right, was 20, 130.
No, I'm saying.
Okay.
Fluorine,
Mhm.
neon,
Uh-huh.
sodium, yeah, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, no argon. Argon, argon, potassium, calcium, iron, radium.
So you just want to say 1 to 20?
Yeah.
Right, so I have to know 1 to 30 for
What?
Andrew. That's 1 to 20, right? Huh? You need to know first 2 groups. Yes, sir.
If you write this right,
Yeah, it's actually bonded. You kind of do all that talking about. Yeah? Huh? No? No, you understand what the theory behind it, like the bond makes it. And we don't have any very structure and it's.
Wow. that was just.
Yeah.
I think I mentioned we need to know. I need to buy you last.
Oh, yes. And you want to, we want.
No, no, I'm talking about them buying now.
Oh, yeah, no, we don't have to.
Right, so when I finish, draw either one of these structures, label it as the structure of NaCl. So you all know what it.
No,
You know what it is?
sorry, salt.
Label it, structure of sodium. Huh?
Not set.
Why do you not say?
Like I eat,
Why didn't you?
because I don't have time.
Why should you take your food?
Yeah.
Yes,
Should you eat?
I can make one or two.
Why does she keep taking food?
Every time when you're not taking one,
You got to do what?
I'm going to.
You gone?
Yeah.
Shakir, you ever gone?
We can laugh.
If I just last answer.
He goes still last. Yeah, she's just.
But I see, I'm just gonna go. Right, after the other man,